Hi, in this tutorial we are going to learn about two things. 1. Quadratic functions. 2. Drawing graphs for quadratic functions. As a definition, it is a polynomial with degree 2. A new term. Polynomial. Polynomial is a collection of algebraic expressions each with non-negative integer exponents, or degrees, and each involves only the operations of addition, subtraction, and multiplication. Simply, x to the power of n. Here, a is coefficient and belongs to real number. N is the exponent, or degree. Remember, it is non-negative. And x is a variable. This is an example for a polynomial with degree 4. How to find the degree? 4 is the maximum among the exponents here. Same polynomial can be written as this, with missing terms, in Q of p. Remember, both of them are equivalent. Is this a polynomial? No. Check the definition. The resultant of this expression will give negative exponent. So returning back to the definition of quadratic function. I hope you have understood it now. Standard form of quadratic function is this. Here, a, b, and c belong to real numbers. But, the term, a, which is the coefficient of x, to the power of 2, won't take the value 0. Why? If it is 0, a, x, to the power of 2, will become 0. Then, it won't be a quadratic function, right? How many solutions are there for x? X equals 2, only one solution. Why? We can rewrite this polynomial as this. Here, the maximum exponent is 1. So, this is a degree 1 function. Degree 1 means, one solution. Always remember, degree directly proportional to the number of solutions. Then what about the solutions for a quadratic function? It is 2. Why? It is a degree 2 polynomial. The factored form of a quadratic function is this. A will have the same condition. P and Q are the two solutions. Here we call them as roots of this function. This is the vertex form. A is vertical scale, and C is the horizontal scale. H and K are horizontal and vertical translations respectively. When C equals 1, we can rewrite the vertex form like this. This form will help us to draw the graph. Graphs of quadratic functions will be like either of these two. For a greater than 0, the function will have one minimum, and for a lesser than 0, it will have a maximum value. Let's draw the graph. For that, we have to convert the standard form to vertex form. But, how? And why? Wait and see. First, take the term a as a common term from the whole expression. The intention is to make the coefficient of x to the power of 2 as 1. Then we have to make a complete square so that we can get x to the power of 2 plus b, x, divided by a. When we expand it, here, we can get x to the power of 2 plus b, x, divided by a, plus b, to the power of 2, divided by 4, a, to the power of 2. The last term is an extra term, so we have to deduct the same term to eliminate it in the resultant expression. Then, if we simplify the rest of the expression, we will get this. We have converted the standard form to vertex form, and, now what? We have to find the axes of symmetry. Let's see how to extract these from the vertex form. In the vertex form, we have to equate this term to 0. We will get x equals negative b divided by 2a. Next, we have to find the places where the graph cuts the y-axis and x-axis. When intercepting the y-axis, the coordinate will be 0, y, right? So we have to substitute x with 0. We will get f of 0 equals c. We can also use the standard form to do this calculation. That is easier. Next we have to find the places where the graph cuts the x-axis. When intercepting x-axis, the coordinate will be x1, 0, and x2, 0. So we have to equate f of x to 0. That will give this first. By solving, we will get two answers. Where are they? There is plus or minus before the square root term. What is the y-coordinate of the turning point? Here, minimum point? The minimum or maximum has to be in the axis of symmetry, right? So equate x with the axis of symmetry. So, f of negative b, divided by 2a is equal to negative b, to the power of 2, plus 4a, c, divided by 4a. We have all necessary informations now. The graph will be like this. All the data have been marked here. If a less than 0, the graph will reflect across the x-axis. How was this session to you? If it was useful, encourage and support us. Subscribe to our channel as well. Don't forget to share this with your friends. See you in the next video. Bye for now. Lots of love from your tutor.